Sergei Semenov was a humble Russian farmer living in Siberia in the early 20th century. One morning in the summer of 1908, he looked up into the sky and witnessed an explosion. He gave the following account. The sky split in two and fire appeared high and wide over the forest. At that moment, I became so hot that I couldn't bear it, as if my shirt was on fire. Then the sky shut closed and a strong thump sounded, and I was thrown a few meters. After that, such a noise came, as if the rocks were falling or cannons were firing. The earth shook. What Semenov witnessed is what is now referred to as the Tunguska event. The explosion flattened 80 million trees, scorched an area about twice the size of Greater London. For several days after the event, the sky glowed ominously all across Europe. But, to this day, the cause of the explosion remains one of science's greatest enigmas. Perhaps the most fascinating thing about the Tunguska event is that although it fits the description of a meteorite, there was no crater left behind. There were no remnants of the meteor left behind, almost as if it had hurtled towards Earth, exploded, and then vanished before it reached the surface. What caused the Tunguska explosion? There are a few interesting theories. The meteoric airburst theory posits that a stony meteor entered the atmosphere at a speed of 54,000 kilometers an hour. As an enormous rock travels through the air at that speed, it compresses the air in front of it, and this compression we call the ram pressure. In contrast to the ram pressure, we have another measurement called the strength, which is a measurement of the maximum stress that a rock can endure before it breaks apart. As the rock gets closer and closer to the surface, the atmosphere gets thicker and thicker, and as the atmosphere gets thicker, the air compression increases, which in turn increases the ram pressure, and when that ram pressure exceeds the strength of the meteor, it begins to break apart and eventually explode. And this explosion produces a strong blast wave radiating away from the meteor. This meteoric airburst theory is the most commonly accepted theory, and it helps that we've seen a similar event occur in Russia in 2013, with which we can draw direct comparisons. The Chelyabinsk meteor. This meteor underwent an airburst explosion at an altitude of 30 kilometers, and being in the age of smartphones and dashcams, this meteor airburst was recorded. When it exploded, it generated a shockwave, shattering windows, collapsing roofs, injuring thousands of Russians, and generating an intense light 30 times more intense than the sun. This meteor was 20 meters wide and generated an explosion 30 times greater than Hiroshima. Compare that to the Tunguska event, a meteor believed to be 60 meters wide and releasing 1,000 times as much energy as Hiroshima. Another theory suggests that there was in fact an impact, and the crater formed by that impact was Lake Checo. The scientists behind this theory still believe there was an airburst, but that there were remains of the meteor that survived it and struck the ground, causing the impact crater that eventually formed Lake Checo. This theory is heavily disputed. The shape of the lake is similar to that of a crater impact, and geophysical surveys of the lake bed even point towards a large anomaly, which could be the remains of the meteor, but studies looking at the lake sediments have suggested that the lake had been there for over a century prior to the Tunguska event. Rather than a stony meteorite, this comet theory suggests the Tunguska event was caused by a comet instead of a rock. Now, comets are made of ice and dust, and this ice and dust would not have had the strength of a rocky meteorite, and so would have disintegrated before reaching the Earth's surface. Plus, the explosion of ice and dust in the atmosphere could have better explained the phenomena of the glowing sky. The natural gas burst theory is perhaps the wackiest theory of them all. It suggests that a geophysical event like an earthquake caused a release of up to 10 million tons of natural gas from the Earth's crust. This natural gas leaked out the Earth and rose to its equal density height in the atmosphere, and from there, all it took was a small flash of lightning. That lightning lit the gas, ignited it, and the ignition followed the gas all the way along the leak down to the source of the gas in the crust, causing an enormous explosion. As you probably gathered, of these four theories, it's widely believed that the first, meteoric airburst theory, is the most fitting, seeing as we've seen a similar event happen before in Chelyabinsk. But just take a moment to consider the destruction that could have been caused had this happened over a more densely populated region. If you enjoyed this video and would like to see more content like this, please like and subscribe. I'm very much looking forward to making more of these.